All right. I think we are live now. Welcome to Actualize presents What on Earth is Redis? And today, my name is Danny, for those of you who don't know me. Most of you probably do know me. I'm one of the lead instructors at Actualize. And I have put together this little rendezvous with Justin, who has also helped create this event. And this is basically going to be a little bit of an introduction on Redis. Justin, who's here, is a senior developer advocate at Redis and is going to give us a little bit of insight into what in the world that is, how to use it effectively, and kind of teach us a little bit of the ins and outs. So I'm going to go ahead and let Justin take it away, maybe introduce himself and teach us.
Awesome. Well, thank you very much, Danny, and everybody. Hello, welcome. Thanks for joining us. I know it's after 5 o'clock, so anytime after 5 p.m. to me is precious and sacred. So thank you for sacrificing a little bit of your evening for that. At least for me, I'm in Pacific Standard Time. So what to expect? I'm going to talk about Redis. I'm going to talk about myself a little bit, how I got into Redis. I'm going to talk about why you should use Redis, why you shouldn't maybe use Redis for some things, and some common use cases, some interesting use cases. I'll talk about NoSQL in general versus SQL, things like that. It's really casual. So if you have a question, please interrupt me or pop a question in the chat room. Hopefully I'll see that, or somebody can flag me down or stop me. And I can answer them to the best of my abilities. So what I'm ultimately going to show you are a couple of different code bases that use Redis. Redis as a cache, and I'll explain what a cache is if you're not quite sure. And Redis as a primary database that will store and retrieve JSON and will have search capabilities based off of some of the entries that you store in there. And we're going to build, well, you'll see some code base. It's basically like discogs.com. I'm obsessed with music, so I made a little music storage CRUD app. Really, really simple. If you know what CRUD apps are, if you've worked at, if you've done it plenty of times, then it'll be really boring. But the main thing I want you to see is me implementing Redis into that code base, so you can give it a try on yourself. And then after that, we'll talk about some possible opportunities of contributing to the Redis code base and getting your name out there. And you know, filling that big green bar, the GitHub bar, if you're out there looking for work. Cool. Does anybody have any questions before I start throwing up obnoxious slides and graphics and stuff like that? Excellent, excellent. Okay, cool. So let me look at the bottom of my screen as I try to figure out what to share. And no, not the desktop. That's dangerous. Keynote. Okay. Oop. Okay, do you see a big, beautiful screen that says, what on earth is Redis?
Yeah. Yes, we do.
Okay, cool. So I'm used to being in conferences, so I'm like talking around with a big, obnoxious Britney Spears microphone. So being in the office is a little weird doing a presentation like this. So welcome, I am Justin Castilla. Go ahead and email me, or keep that email, justin@redis.com. I'm more than happy to answer any questions, get you out of any Redis binds, or direct you to one of our engineers that knows more than I do. So who is this guy? Why am I bugging you at 5:30? I'm based in the Bay Area. I was an instructor lead at General Assembly with Danny. So Danny and I worked together, different cohorts, but worked together. We, you know, broke bread, we ate lunch, we talked about how great our students were. I was a software engineer at Sauce Labs, which is an automated testing company. So if you hate testing, then you'll love Sauce Labs. And then I am now 2 years at Redis as a senior developer advocate. Now, what does that mean? I talk about Redis. I'm not an evangelist, or I'm not going to say Redis is like the best thing in the world. I'm an advocate where I say, if you want to use Redis, let me show you how to use best practices, and let me connect you to resources. I also do a lot of YouTube videos within our YouTube channel, Redis Inc. I highly recommend you check that out if you want to learn more about Redis and some of our data structures. I also operate a couple of our different online courses that we have. So you'll see me in a lot of those videos, and I create the homework and the tests and the content. And basically, I am the go-to Friday guy for Redis as far as education and advocacy goes. What do I like to do? I like converting ambient light sources into sound and noise. That's my new COVID hobby. Behind me, I have a soldering workstation where I put together, there you go, my little Eurorack modular system, and I capture and record the ambient light from outside my window, and I record it over time, store it in a database, and play it 10 times as fast. It's pretty amazing. I own 2 cats, Basil and Bird down there, they're cuddling, and then 4 chickens, also a new investment, Eulalie, Josephine, Aaron Turner, and Bug 2.0. They give me plenty of eggs, and they're scary as hell because they're all raptors. I am music obsessed. I play music, guitar, bass, synthesizer. I love playing it. I love going to shows. I just saw Bjork a couple weeks ago. It was amazing. And I use bullet points too much, but I don't really care. So I get paid to do it. All right. So what's going on? What are we going to do? I'm going to go real quick over Redis, like how it's designed, what the data types are stored within it. So we don't do SQL. We don't just do rows of true, false, text, and numbers and floats. We do a lot of other interesting things to store our data. We're going to go over a couple different use cases. So we're going to implement a queue with our list data structure. We'll make a player leaderboard with sorted sets. So who's the top 5, who's the top 3, top 10, things like that. We'll go over the concept of caching, and we'll use strings and key expiry. And that'll be not a super thing that we're going to focus on too much, because there's a lot of resources out there from inside our house and outside about caching. And then we'll talk about searching and indexing with Redis Search and Redis JSON, which is really exciting. In the chat window, I included this link below, Introduction to Redis. It's just going to be a quick little cheat sheet. It's going to show you what I'm going to be typing into the command line interface to interact with Redis, and just sort of give you, something to look at instead of just hear and see. So again, as an instructor, I know that there are different ways of learning, visually, by practice, and by repetition, and by sleeping over it, and then waking up the next morning. So I want to give you all those resources so you have, more growth from this rather than just the next, hour and a half, what have you. Okay, so what is Redis? Redis is a database data store. It was born in 2009 in Italy by Salvatore Sanfilippo. He's also known as Anti-Res. So you'll see in Stack Overflow, in Reddit, and in Hacker News, this guy named Anti-Res who actually knows everything about Redis. He does. He wrote it. It was lovingly handwritten in C, which is actually really surprisingly easy to read. I hate C. It's scary. It scares me. But when you actually open up the code base, because it is open source, you can open up the code base. You can actually see how things work. So I had noticed this little quirk a long time ago working with some of our string interpolation. And I looked in the code base and I was like, oh, that's why. And I submitted a PR and it got fixed. So it's pretty cool. But yeah, it's open source. So you can use it locally. You can install it. You can create clusters of it. You can create high availability. You can use this in any kind of cloud storage service around the world, and you'll have perfect availability and persistence. That's Redis. Now, Redis, the open source, doesn't actually pay my bills. I work with Redis Inc., which is kind of in part with Redis. We offer cloud solutions. So we offer cloud hosting of Redis. We also create and work on Redis modules. And we also have this big scary arm called Redis Enterprise, which isn't really scary. Those are for the larger companies, banking companies, online security, things like that, when they need a huge amount of Redis storage solutions and Redis servers. And that's when you start getting into the really big, high global availability, active data warehousing, stuff like that. Me, all I got to worry about is how fun open source Redis is, and how fun Redis Cloud is, and getting all these different modules up and running, and making it easy for everybody to run it. The most recent stable release is 6.2.6. That's the one I'm going to be using. We're going to be releasing 7 soon, so it doesn't mean a whole lot to you, but I think it's exciting because we might be including functions capabilities. So right now we can write in Lua, which is this little tiny scripting language that looks a little bit like Python. But soon we're going to be able to integrate JavaScript into writing functions that just automatically happen on our data store elements, which is cool. So no SQL at all. No select star from where, any of that. We store our data as data structures, as key value pairs. So string is a data structure. A list is a data structure. A set or a sorted set is a data structure. And hashes, which are basically kind of baby JSON where you have keys and values within a larger key. And I'll go over that a little bit. But yeah, there's no actual row of data. So we actually allow you to choose the right data structure that makes sense. We also don't we don't automatically assign the key for all of your items. You actually have to create the key or index or what have you, which is actually pretty fun. And it makes life sometimes a lot easier because you know exactly how to find what you're looking for. Also, this is really kind of cool. Data for Redis is stored in RAM, not in the spinny disk, not in a hard drive, not in a solid state drive. It's in RAM. So you're like, well, doesn't that munch up your RAM? Not as much as Chrome, not as much as Firefox. Because it is a data structure and because it's mostly just text, we can actually compact that down really, really hard. So you'll be really surprised about how much you can actually store. And we don't have people, unless you're an enterprise level company, you don't go over terabytes of storage. You're down at gigs, which is not a whole lot, especially in production. And there's lots of like a la carte plug and play things that you can add to Redis. So optional persistence, clustering, high availability. We have courses in within our university on, setting up Redis for scale. So making it larger and larger and larger. And if you should lose like a warehouse, you're not going to lose all of your data. And then we also have optional modules that integrate into the core Redis system. So we can actually have JSON stored within Redis, which is really exciting and I think makes everything the bee's knees. And then search, which includes querying and indexing, full text search, suggestions, fuzzy search. There's an AI model that we can actually cram into Redis to help identify, is it a hot dog, is it not a hot dog? Probabilistic data structures like hyperlog, log, Bloom filter, all sorts of weird stuff, and automation. So we can actually write Python scripting to just automatically work on our data. So it's really cool. Also, this really weird, interesting thing is that most of the people use Redis. It's not a brag, it's just an interesting quirk. We are used the majority of the time as a cache. The cache is kind of like just like a quick little memory retrieval system. So it doesn't actually, make old man SQL, spin up its old hard drives and look at all those rows. Redis is kind of like the whippersnapper that's really, really fast. It's more expensive for memory, but it's a lot faster. So that's why we're used as sort of like the go-between between the SQL server and your actual server handling the routes. Okay, so let's talk a little bit about the data structures. Some of these you should probably know. Some of these you've worked with before. Some of you might have heard of these and whispered in dark passages and in lower levels. Strings are just words. For us, it's words. Strings are numbers. They're binary safe. So if you can encode something into binary or base 64, you can store it in Redis. So you could, encode images, MP3s, songs, things like that, and you can actually store it in Redis. It's going to cost a lot of space, but I mean, you could do that if you wanted to, if you really wanted to flex. Lists, which is just, a simple list, a collection of things, numbers, what have you, anything you want. A hash is, with JavaScript, the best comparison I can make to a hash would be an object literal. So properties with values. And you can store, the only limitation with our hash is that you can't have any kind of embedding. So it's all flat. It's all one level. So you can't have a nest within, or a list within a hash, or another hash within a hash. But we've gone around that, which isn't a problem. Streams. Now, streams are exactly what they sound like. It's just a long flow of information where there's two parts of that data structure: a producer, somebody who's producing information, and a consumer, somebody who's consuming information. So think of, maybe like an airport. Somebody is creating data by putting weather data into the computer system, and then all of the different weather control or air traffic controllers are actually reading that weather data. And so that's a two-part system, streams. A set, I'm going to go over that, so I'm not going to talk about too much. Hyperlog is a weird probabilistic data structure that says, yeah, I think I've talked about this before, or yeah, I think I've seen this before, or I don't think I have. No, it's probabilistic, so it's not 100% accurate, which is actually really fine when you're dealing with millions and millions of items. That's good for like checking, oh, has somebody ever created a username for this website before? It'll check very quickly without having to go through everything. And that's a weird data structure. It's kind of fun to like spend your own time on. I won't go over it in this talk, but it's a good interview question for sure. Sorted sets are like sets. I'll talk about that in a little bit. Geospatial is a special object that is shared and understood by many different programming languages and frameworks, where it's a pair of coordinates, and basically they figured out a way to codify coordinate systems, latitude and longitude within the world, and how to find how far you are from that location, or if we drew a circle around that as the crow flies, how far you would be, things like that. And that's really cool. We have that built in. And then bitmaps and bit fields. I made a couple of videos on these and they're really fun, but TLDR is just like flipping a switch if it's on or off. Very nitty gritty stuff that you probably wouldn't ever have to worry about in today's modern systems, but it's kind of fun to know. So I was talking about key value data storage. Everything is a key. That's how we call things. So key Justin, value me. Basically, that's what it is. It's like names. You can say that it's a name. You can see here, it looks like a little bit of like a command line. I'm saying set cat mocha. I'm saying, hey, I want to set a key called cat, and the value is going to be mocha. So Redis uses the set get nomenclature. So set to create, get to actually retrieve it out of the database. And the cool thing is you don't actually have to instantiate an empty variable before creating it. You can just do it all in one go. So set cat, set dog. I don't care if it exists before. I'll write over it. I just don't care. We give you the power. We don't actually want to protect you or hold your hand. You make your own decision. We're all grown-ups here. And then this is kind of the structure of how Redis works. We have the Redis Core as illustrated with that red Redis logo. And then we have the module API. So we have all these different a la carte options that you can include into Redis. And I have here listed Redis Search, Redis JSON, and Redis Graph. And Redis Graph is like a graph database structure. So similar to how like social media databases are set up with vectors and edges and connections and things like that, which is really cool and solves a lot of great problems when you need it. But if you don't need it, there's no point in actually having it. So that's why we actually make all of these a la carte, so you can keep what you need and not have too much bloat. So how do you interact with Redis? Well, there's a couple ways. With SQL, you can just go into the SQL command line, and then there's a couple of different like GUIs that you can use. Well, similar to us, we have the Redis CLI, Redis command line, where I can type out set and get and other various commands. We also have our own GUI called Redis Insight, which allows us to connect to our local Redis instance or a cloud instance or anything like that. And it gives us just more information, more statistics about that data. That's really, really great when you're first starting off and just checking to make sure that everything is being stored properly how you want. And then you'll see me actually using that today. And it's free and you can download it without a problem, of course. Okay. And of course, client libraries. We are working constantly on our libraries. In fact, in 3 days, everything I'm going to show you today is going to be slightly outdated. We're releasing yet a newer version. The person that was coding out the Node.js version is like, oh, just so you know, there's a slight breaking change to the library coming out on Friday. I'm like, okay, cool. I won't talk about that. So we're not going to go over that specific data structure, but it's okay. It's a bad data structure. So we have coverage for, these are 2 examples of me writing in Python and in Node. And our libraries are just Redis. So Ruby loves Redis. I think it's actually built in as the default cache, I heard. I'm not quite sure. I haven't looked at Ruby since I was a wee one. But we are actively building out super, super fresh object mapping clients, for .NET, Java, and JavaScript and Python. But any language that you want to get into, we do have some kind of client, either official or unofficial. So Go, Rust. I think there's even one for C. So you're well covered. So let's actually get into the technicality. Lists. I'm going to hope that everybody understands what lists are. It's just a collection of things. So it could be objects. It could be strings, numbers, what have you. And we, for Redis, we store it strings or numbers, which are basically the same as strings. Lists don't actually contain anything else for Redis, but that's not too much of a problem. So the use case here is queuing. A queuing is just a fancy British way of saying a line. So you get in line in the back and you wait your turn, because we live in a society. And when everybody else in front of you has received the service or whatever they want, they leave, and then it's your turn. And then you do whatever, and then you leave. So you can actually utilize that in a list. And queues are used in development all the time, because maybe you have a queue of people buying tickets to Ticketmaster, which I hate. Maybe you actually have to get in a queue to get into a Zoom call. Maybe you're asking kind of for like some higher cost service from a website. Well, they can't do it all at the same time. You have to actually get in a queue and you have to wait. And messages. Sometimes you have to wait for commands to get to an API by going into a messaging queue. So we can do that with Redis. And that's one of the first things that people end up doing, a queue or a stack. And just some nomenclature, the beginning or the leftmost part of the list, I'll call the head. And the rightmost part of the list, I'll call the tail. And sometimes you want to start at the left or start the right. It doesn't really matter how you implement that. You just have to be consistent. But this is how I like to do it. So the first entity or element in our list is going to be A, and then B, and then C, and then D. So the first person or element to receive service is going to be A, and then they're going to go away. The last person is going to be D, which is at the head of the list. So let's actually apply this to a real world scenario. Let's say that there's a hotel that has Redis implemented in their system, and the front desk gets a call from a couple different rooms saying, hey, I would like some cleaning service. Hey, can you order me a taxi? Or can you help me bring my luggage to my taxi? Or like, I'm a sweaty Betty. Can I have extra towels? I don't know. There's a lot of weird things that people ask for in hotels. I don't ask. Now you have, in this case, with the queue, 2 different things, a producer and a consumer. Now, these are 2 keywords that you're going to hear throughout your career, or you already have, producers or consumers. Same with streams, that data structure, producer and consumer. Somebody produces the data, somebody consumes the data. Everybody's happy. The producer doesn't have to be within the same system. The producer can be a microservice or a sensor across the world that's just feeding data into a shared data structure. And a consumer can be, again, across the world, consuming it as they see fit. You can have multiple consumers. You can have multiple producers. Another word for this is pub sub, publisher and subscriber. Just a paradigm that's really good to know. So check that out, write it down. Don't do it now because I want your attention. But basically, with lists, and I have the commands here, for queuing, there really is just two major action methods that we'll call L push, R pop. L stands for left. So we're going to push an element into the list from the left. R pop is going to remove or pop off an element from the right. Again, Redis lets you do your own thing. So we have L push, we have R push, we have R pop, and we have L pop. So you can do whatever you want. We don't care. You know, JavaScript pop is like off to the right, I think, and that always bugs me, but whatever. So as we can see here, I'm doing L push jobs. Jobs is going to be my key. And then in that key, I'm going to push one element. Now you can see here, L push jobs, and then we have a string. It looks like JSON inside a string, right? Well, sure, it could be. And we're going to push one single string item into our list. And now if I want to actually pop or remove an element, I would do rpop jobs, which is saying, hey, I want to remove from the rightmost item of this list from the key jobs. So let's actually switch over to me coding. So you don't have to code, you just get to sit back and enjoy. Okay, can you see a very boring looking little terminal?
We can indeed.
Okay, excellent. I love boring. So I'm going to start my Redis server. There we go. You know, it works because you can see our happy little cube. And then I'm going to start up. Oh, 1 second. It's only staring at my server. That's not very interesting. I want it to stare at my command line interface. There we go. Okay, so you should probably see this. It's just Redis Cloud 6379. This is the prompt for Redis command line interface. You're not going to use this in production. You're not going to be frantically entering text. This is all going to be automatically done by your framework, so don't worry about that. Let me just check that I know that it's actually working. So I'm going to go ping. I'm going to ping a server. Pong. So it's coming back to me. I'm running this locally on my system. So it's not connected to the cloud. I'll do cloud connection later on. I just want something quick and dirty. So I'm going to call it L push. And you'll see this like little cloudy key element and an element. Our command line interface comes with hints. So that's kind of sweet of them. So this is my key jobs. And I'm going to put in my value, which is going to be room, lowercase room, 101. And then the job is going to be cleaning. And unlike, that's not right. There we go. Unlike SQL or like MongoDB, I don't need a schema at this point. I don't need anything. I can put whatever I want there. I can put a picture of Jeff Goldblum after all these, if all I care. It's mine. It's my world. It's like the Bob Ross of databases. So we have one element. Let me actually copy paste another element, because once you've seen it before. So now room 309 wants a taxi and their luggage pulled down. Fine, whatever. You'll notice this return value integer too. That's telling me that there are two elements now so far in my list. And now room 484 wants extra towels. So don't ask, don't tell. Whatever goes on in there is fine. So now we have three elements. So there are some commands that you can use to manipulate this. If I want to inspect this list, I'll call lrange, and that just goes over the entire list. So the key again is jobs. And then I'm going to start at the index of 0, which is the beginning of the list. And then -1, if I don't know the length of the list, I use -1, similar to JavaScript and other programming languages. And there we go. There's my list. That's awesome. That's fantastic. It's amazing. There. Now you know why you need to buy Redis. Now, it's just a quick little inspection thing. So now we have, L push, L arrange, and then of course we could do L pop if we want, but we're not. We're doing a queue, so we're going to do R pop, and that's going to take the rightmost element of the queue, which is the first element in our list. So R pop key, jobs again is the name of the key. And there we go. It removed and returned the first element in the list. Room 101, they need some cleaning. Cool. Is that very exciting and earth-shattering? No. When done in sub-millisecond speeds across millions of things, it's kind of cool. Let me show you something else that I have going on, and that is going to be our actual GUI. This is how we actually interact and inspect and basically sniff our data structures. So this is jobs. This is the key. It shows me it's a list. It's 205 bytes. That's not very large. That's pretty tiny. And I'll click on it, and it'll show me in here the index and the elements, things like that, the length. I can actually manipulate data in here. So let's be polite. Thank you. And oops, taxi, please. And I can make updates right there. Also, and I'll switch over right here, there's a command line interface that I can actually run right here. So I'll switch over to this because this is just a little bit easier because we can look at the data as we go. It's actually a little big. Make that a little bit smaller. There, happy medium. So yeah, again, the Redis Insight's nice because you can use local database or your cloud database. You can look at the data. You can actually enter code in here and just give it a try. You enter code in here. If you like how it works for you, then you can actually convert it into the client library alternative within your programming language in your framework, and then you can actually move on. It gives you other statistics too. So far, my entire huge database is taking 1 megabyte. I've used 0.08% of the CPU. So you can actually get a lot of interesting information. Total keys, I have jobs in my name, which is a string. And then all of my connected clients, I have 4 connected clients, which means that 4 different things are sniffing this database on my computer. So cool. All right, so let's actually switch over to our great slide, and then let's move on because, well, I have more to talk about. Any questions so far? We are starting off with a little bit of a basic concept of lists in the grander scheme of things, but we'll ramp it up. All right, so now we're going to talk about sorted sets and sets. So what is a set first? A set is a collection of unique values. Now, a list is a collection of values where you can actually have repetition and non-unique values. So you can have multiple Justins, you can have multiple instances of number 4, or 42, or anything like that. And that's perfectly fine with a list. With a set, you only have unique values, so nothing ever repeats. So it would be logical if you had to keep a roster of students, it would be a set because you are all unique and wonderful. But a list would be like a list of laptops because, you know, most of us have Macs, and so you can only have so much uniqueness of those. But shout out to those who have Windows and Linux. If you add an element to a set that already exists, it will just be ignored. So you can try adding multiple times, adding the same value, and it'll just be like, whatever, dude, I already have it. So it kind of protects you from yourself. Now, with a sorted set, there is a numerical score associated with each element or member that you actually dictate. So it could be anything. It could be age. It could be, bank value, asset value, number of pets, number of hairs on your chin. It doesn't matter. It's just a score that is given by you to this member. And once it is inserted into this set, because of those numerical values, it will be automatically sorted for you from lowest to highest. Lowest being at the beginning of the list, or beginning of the sorted set, and the highest being at the end of the sorted set. And that's really, really nice because we sort a lot because people want to know sorted things. What's the cheapest thing I can get? What's the most expensive thing I can get? What's the highest amount of ratings? What's the lowest amount of ratings, you know? So sorted sets actually work a lot. And one thing that I like to do is create a leaderboard. And again, self-promotion, go to your YouTube, look up sorted sets with Redis. And we kind of dig way into like the different commands and more about sorted sets and set intersections, set union, things like that. But for now, we can just think of a leaderboard and just sort of like watch me as I code. So only 2 commands to actually use a leaderboard, which is kind of great. And the commands get a little funny at this point, but it's okay. You know, we're all funny people. So zadd or zad adds a member to a sorted set. Why Z means sorted set? I don't know. You know, and anti-res knows, I don't know. And then, so basically we add 2 things to create one member, a score and a member. A member would be a string or a string value or a number. And a score is like a number. So that's a constraint. And then the more you zadd members into your set, your sorted set, the more it's going to be sorting. And it's going to always be from lowest to highest. Now, zrange is a command that will return back to you. It will retrieve that actual sorted set. Now, range allows you to dictate how many you want to receive back from the beginning to the end or what have you. It listens to whatever you want. So say we had like 50,000 players in a game server. You don't care about the specific rankings of 50,000 players at one time. You want to see the top 10. And then after that, you want to see the next 10 and the next 10 and the next 10. So it's pagination. Redis wants to deliver things quickly, so they're not going to send you that whole chunk of data. They'll say, do you want just 10 to start with? That's a lot faster and it's a lot smaller. It's a lot less taxing on your system. So zrange gives you that ability. So here in front of me, we have Guy, Brian, Justin, Steve, Simon, and Suze. This is the entire developer advocate and community management team at Redis. And we're all playing Minesweeper, the world's hardest game. So we want to keep score, and we are going to create a sorted set. We're going to place members into our sorted set with their associated value. So Guy just started and he rage quits Minesweeper all the time. So he only has a score of 12,010. Suze is absolutely obsessed with Minesweeper and is amazing at it. And so her score is 86,590. No matter when we add these members with their scores, it's always going to sort from the get-go. So that's really, really nice. So let's actually code this out. Let me switch over to my GUI. Okay. And then let's start adding people. I'm going to add one person first in no particular order. I'm going to add Brian. So I'm going to call it team scores. And then I'm going to give, let's see here, the number of, let's see here, 23,740 and Brian. There we go. Woohoo! I have one item in my sorted set. And let's look at this real quick. There's my sorted set, team scores, and I can observe it. There's Brian with a score of 23,740. So let's actually add a couple more. So now we're adding quite a few more. We add Guy, Justin, Simon, Steve, and Suze. And again, you see all these little bracketed items and words after what I just entered. Those are all hints. You can turn that off if it really bugs you, but I think it's really helpful because it tells you all the options that we have with these commands. I'm showing you baby step commands. They can get pretty intense after a while. You can do some pretty interesting mathematical formulae. So I'm going to add all them. It's going to say integer 5. Again, that gives me 1, 2, 3, 4, 5, how many I just added. And then I'll refresh here. I'll look at sorted set. I'm sorry, refresh here. And we'll see Guy, Brian, Justin, Steve, Simon, Suze. And this is the actual order of the sorted set, starting from the beginning, ending at the end, left to right, lowest to highest. So what if I actually wanted to see all of my objects via command line within my sorted set? So we'll do Z range, team scores, saying look at the key team scores. And I'm going to start at 0 as the minimum, the 0th index, and -1 as the maximum index. And that gives me, cool, the members, Guy, Brian, Justin, Steve, Simon, Suze. Not super informative. I'm going to have to get some more information if I wanted to actually display this on a lobby page or, on the homepage of my game to show who's number 1 and things like that. So let's actually use some of the options that are listed here. I'm going to do rev, which is reverse. So let's build this. Let's look at this. All right, so now it's reversed. Now at index 1 or number 1, we have Suze, who has the highest score, then Simon, then Steve. Okay, cool. So now we're actually getting somewhere. And then I also want, looks like an option there is with scores. So I'm going to enter with scores, and that's going to give us the scores. So now I have Suze, Simon, and Steve, all of their scores. So that's actually pretty helpful. And I can go instead of 0 to -1, I'll do 0 to 2. And there we go. We have the top 3. So I will actually enter this, I'll convert this over to my client library if I ever want to get the top 3 scoring players. And there we go. Their actual member names and their actual scores. And again, these don't have to be member names. These can be referrals to other keys. So it could be referring to another username. So I could actually link to their username if you want to look at that person's profile. Or it could be any number of things that you want. It could just make sense to you for you to use within your client to pull up more information. Fun fact, you can even store HTML into your keys if you were so into it, or into your values. So yeah, that's a sorted set. Any questions so far about that, or anything I've covered so far?
Why is your score not higher, Justin?
I hate Minesweeper. I hate it. I don't like it. My mom loved it. She used to curse at the computer when I was a kid. Like, why is mom yelling at Minesweeper? But that's for another talk. All right, so that's a sorted set. Now let's get into something a little bit more complex. Caching. I always love to look up Wikipedia because I don't believe anybody until Wikipedia says it. That's not dangerous. A cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. Okay, boring human example. You have a bag of Takis in the kitchen. Haven't been opened. They're delicious chips, super spicy, very crunchy, very delicious. And you go there, you go all the way to the kitchen and you grab one Taki and you go to your computer and you go back to work and you eat that Taki and it's glorious and it's delicious. But the problem is, once you grab one Taki, you grab more. I mean, no one just eats just one chip. So what do? You go back to your kitchen, you grab the Takis, but you make a little bowl of Takis for yourself, a little snack. And then you put that on your desk and you eat Takis and get chip dust all over your keyboard. But some important things. You don't have to go all the way to your kitchen, open up that cupboard, loosen the hinges, put wear and tear on your kitchen. And it's a lot faster reaching into your bowl, into your chips to eat your chips than going into the kitchen for every single chip. So just drawing on my experience, might be different from you. But there are a lot of different uses for caching. Caching is absolutely everywhere. People caught on really quickly that Redis is a great cache because we don't have to join tables. We don't have to go through relationships and do stuff like that because we're kind of like a quick and dirty data store. So just creating data very quickly and then retrieving it very quickly is what we're really great at. A lot of people don't know that we're actually beyond just a cache, which is kind of fun to show people. Another really cool thing, especially when you're kind of like jamming out on like new APIs and things like that, is to cache your API responses. No, it's not bad at all. It's not illegal or anything like that. And it's actually probably appreciated from the third-party APIs that you're using. So let's look at this actual slide right here. Your application code is contacting a third-party API server, getting that information and sending it back to your code, and then you're sending it back to your user. Now, that could be anything. That could be chicken Florentine recipe. It could be beef bourguignon. It could be a quinoa salad. I'm excited for dinner tonight. These can all be recipes. Now, I pulled that up on my computer, and that's cool, but then like maybe I'm like distracted and I'm going somewhere else. I'm going navigating, preparing for this talk. But now I go back to the website and I refresh just to make sure that I have the recipe again, and it comes back to me. So I actually requested that recipe twice. I'm only going to be cooking that dish really once tonight, so that's kind of wasteful. And if you pay for API access by the count, by request, or like request per hour, that could be actually kind of bad. When you have like people that are obsessed with the weather, or I live in California, when we had like smoke and the sky was red and we thought the world was going to catch on fire, and it did. I was refreshing the air quality index like every like 20 seconds when I was really scared. And that's pinging third-party servers. And I was like, wait, you know what? I'm not being a good net citizen. I'm kind of taxing this API, and I'm maybe costing a lot of people some money. So what I do instead, I was like, oh, I'll make a cache so I can pacify myself. Now a cache basically says, you looked for this one item. That's kind of cool. Instead of contacting that third-party API, I'm just going to store a copy of this just for you. And that will work really well for recipes, weather, things like that, songs, album covers, what have you, things that you look at often in like a list. Some interesting things to think about. You can cache a recipe, literally the whole HTML or the ID or just the text or what have you. You can cache that for a long time, because recipes don't exactly change. Pancakes don't change. You can add or whatever. Weather changes. Air quality changes. Schedules change often. So that's interesting. Caching actually has this habit or structure where you cache data, you store data for quick retrieval, but not forever. Things change. So weather is an excellent example of caching with like a time limit. In California, within Oakland, I'd say it's safe to assume that the weather changes every hour. It's not super drastic, like somewhere in the Midwest or the South, where you actually have, weather and seasons, or the East Coast. California is just like, yeah, it's kind of outside. Sometimes there's smoke, sometimes there's heat, but it's just whatever. So I would say caching weather for an hour, especially if you're in like California or in Northern California, would be a good idea. So let's look at this actual slide. Your application is going to first look at Redis as a cache and say, hey, do you have the weather for my zip code 94606? And if Redis has it, it will say, yeah, I do. I have it. Here you go. And you can display that to the user. If Redis says, sorry, I don't actually have it, you'll actually have to go to the third-party API. Then you'll be like, okay, no problem. I'll go to the third-party API, look up the weather for 94606, and then we'll actually serve it to the user. After it gets served to the user, it will be stored in the cache. So the next time somebody actually says, hey, do you have this weather? Redis will be like, you know what? I got it. Let me give it to you. And it's just so much faster. It saves the API, third-party API traffic and bandwidth. It saves your service, possible charges or money. And there is a noticeable change in speed. This is actually really kind of cool to see what happens when you contact a third-party API that has sensors and databases and SQLs and who knows what else they have. And when you're just using Redis, which is just in-memory data store somewhere in the cloud or in your local warehouse. So we actually set just keys. That's all you need is set strings to keys. And the little extra thing we do is we set an expiration on them. So you will set a key for, say, an hour, and that string value will be stored in your database for an hour. And then after that, it can't really be considered relevant or valid. So it'll just die, it'll go away. So that's actually really useful, because when you have people contacting your website for weather over and over and over again, you'll start getting a lot of actual pieces of cache within your database. And between expiration, natural expiration of these strings that you create, and eviction policies, which is something when your database gets too big, it needs to figure out how to remove some of them logically. It saves you on memory, and if your database ever gets too full, it'll just hang, which is scary. So setting an expiration or a time to live, TTL, on a key is actually a very smart and wise move that a lot of people do. So let's actually look at this in a coding example. And I'm going to hop on my terminal. I'm going to exit here. And then I'm going to go to introduction to Redis. And then I'm going to open up this right here. Now this contains a lot of the code samples that I'm using. I'm also going to include a caching example, so we can actually see caching in action. Just do some administrivia here. And there we go. Okay, so I tried to make this as friendly as possible to see and understand. But basically what this is going to do, this code is actually going to contact Open Weather, which is a fantastic website to just play with APIs, just to get your feet wet, and also to find out what the weather is. So just some things to know. You need to get your own free weather API key if you actually want to play along at home. But basically what happens is I request a function to tell me what the weather is. I pass it a city, and it's going to connect to the API. It's going to first connect to my Redis cache and say, hey, Redis, do you have that city? My Redis is going to say, yes, here it is, or no, I don't have it. And if it doesn't have it, then it's going to go actually to the third-party API and retrieve that information. So let's look at the code. Here I am checking my Redis client if I have a certain weather city. So if I pass in Oakland, it's going to be, this is a key right here. This is generating a key dynamically, weather, Oakland. So again, you create your own keys. So my key is going to be weather, Oakland. And I use that colon, a lot of us in Redis actually use that colon to delineate logical parsing and logical breakdown of what you're looking at. What is it, a pronoun or is it a noun? Is it something that's unique or not? So just basically we're right here looking for whether or not we have Oakland in our cache. If cache entry, which basically says if Redis returns an actual cache hit, which means a hit is, yes, we have something in the cache, then I'm going to parse that cache entry into JSON, and then I'm going to actually return it back from this function, and I will receive my cache entry, and it'll tell me, oh, by the way, this actually came from the cache, so I can actually see it when I'm demonstrating it. If my client, my Redis client, does not have the weather Oakland or weather city that I pass in, it's going to skip all of this, and it's going to say, no, I don't have it. So we're actually going to contact my API, the third-party API. And so you'll see me calling Axios here. City endpoint is me contacting the third-party endpoint. And that's my API response, which is set here. Now, before I send it back to the user, I want a copy of it to send into my Redis cache. So here I am calling client set. And again, I'm creating the key here, weather : Oakland. And then I'm going to call JSON stringify API response data. This is taking that JSON response that I received from my API, my third-party API, turning it into a string, because I can store strings until the cows go home into Redis. And then right here, EX 60 times 60, that's just me saying I want to store it for 60 seconds times 60, so an hour. After an hour, that string will be removed from my cache because it's not valid weather anymore. The weather right now, 30, bullshit, it's not 37. Anyways, it's going to change within the hour. So I know that for sure. So I'm very confident that if I set something to expire in an hour, the new data will be better, because I don't want to like give them ancient data, because then I'm a bad application. All right, and then I also added some timings here when I actually call my function to see how many milliseconds it takes to contact the third-party API and how long it takes to contact my local Redis instance. So let me call. So let's see here. I have city set to Oakland, and then I'm going to call it here get weather city. So I'm going to call node caching example. Lowercase caching example.js. Pretty sure that my API key is stored nicely in my environment variable. Okay, so here is the JSON response from my API, my third-party API, because I haven't looked at this in over an hour. So it's overclass clouds, which I can verify. Feels like 4.95 Celsius. Does anybody know what that is to Fahrenheit? 40 degrees. Yeah, I guess it is actually kind of cold outside. That's cuckoo bananas. Okay, wow. Visibility is 10,000. Here's all my information that is from my local area of 94606 or Oakland. And then yeah, so we have the source. This is really important. Source API, and then response time 192 milliseconds. That's pretty fast. So that's good on them. So now I'm going to call this again. And if everything worked, I have cached that value, and now I'm going to receive that cached JSON instead of actually calling my third-party API. So I'm just going to call this again. Same exact information. It's still friggin' cold. Yes, source cache. Ladies and gentlemen, the whole reason I am here and I get paid, the reason I have velvet curtains and I have such wonderful synthesizers is because of that response time. We are fast. That is 2 milliseconds. That is an unoptimized, straight out of the box, just a MacBook Pro running Redis at 2 milliseconds. Now, if you were running this on a server somewhere, an actual development or production server, that'd be faster. That'd be sub-milliseconds. And that would be on your own hardware to send back to the user rather than you actually contacting your third party. So that's kind of cool. And that's really pretty interesting. This is vanilla Redis right out of the box, version 626. And it's not a big piece of JSON, but I mean, it doesn't really matter how big the JSON is. That response time is how fast we can actually query and get it back. So that's really exciting. That's what makes Redis a fast cache. Now you know why a lot of people use this, why it's built into things like Ruby on Rails, I think. I think Django also uses that with Python. So that's really cool. And I can actually change this. Let's do another city. Anybody want to call out another city?
Chicago.
Oh no, it's gonna be so cold.
Yeah, I just want most of the Actualize students are located in Chicago. Actualize is Chicago based.
Oh, cool.
So let's talk about how these Arctic foxes that cats for humans live.
I was in Chicago last year. It was so beautiful.
Yeah. No, Justin, I'm with you on the cold. It's 40 degrees out. To me, that is freezing.
Yeah.
And I can understand why you wouldn't want to go outside.
No, my oranges are gonna get cold.
No.
Okay, so we're looking at Chicago. You have overcast clouds. Feels like 12 degrees Celsius. Is it really 54 degrees out there?
Can we confirm if that's true?
Somebody look out the window.
Why?
I don't know.
No way.
Huh.
23?
Well, I guess that's Northern
Did
California.
this somehow get converted into imperial units?
Oh, maybe. I don't know. That's interesting. Might be 21 degrees. But
Actually 21 degrees Fahrenheit out.
Chicago.
Chicago.
Let me look off onto some other. Now I'm just morbidly curious. Oh, it's 24 degrees it says there. So I'll have to find out why I got that value. But the main thing is, this is what you get when you use free APIs. So it was 182 milliseconds from open weather. So they're fast. They're still very, very fast. Let's call it again because I have it cached. Bam, 2 milliseconds. So yeah, it's pretty awesome. I love doing that. It's just really cool. Let's switch over really quick to Redis Insight, which is me looking at stuff. Let me refresh it. And so now we have our two keys, weather Chicago, weather Oakland. You'll notice this TTL, that's time to live. So my previous keys that I created, they don't have an expiration. Excuse me, they don't have an expiration date, but my cache does. So 58 minutes for each of them is when they're actually going to expire. And again, the size of that JSON is 568 bytes. It's not bad at all. That's good. And there we go. That's the actual value. Because remember, we're actually storing these as strings. So you can just take this into your client library, into your framework, and then deserialize this back in the JSON. And there you go. And then there's the TTL, 3,472 seconds. I refreshed that. Now it goes to 3,452 seconds, as you will. Cool. So that was caching. Everybody loves Redis for caching. I love everybody for using Redis for caching. It's really good. And people either run this locally within their own infrastructure because, again, Redis is open source, or they'll use it as a cloud service within redis.com, or we're everywhere. You can use Redis Cloud or Redis services within Microsoft Azure, Google Cloud, or Mother Amazon. So we're friendly with all of them. We're all great friends. They use us, so there's not a problem. If you're using nothing but AWS, then go ahead and stick with it. But we just like to be an alternative. And also you can just roll your own, because why not? So yeah, that's my little talk about that. So now, before we go on to something even more exciting, before I talk about Redis search and Redis JSON, does anybody have any questions about caching or anything like that, or anything so far?
Michael has a question, and I will unmute you to ask your question.
Let me see here.
Can I do this?
There you go. I did myself. Thanks.
Oh.
Just a quick question. I just want to confirm on the caching. I think I know the answer to this, but we would have control over that time to live, right? Because I could think, obviously in your weather example, yeah, an hour seems appropriate, but say if I was storing historical stock prices, closing prices, every 24 hours would be fine. I probably want to update it every day, but I don't need to update it more than that.
Oh yeah, absolutely, absolutely. So you actually can dictate the time to live at inception of that key, or you can even alter it while it's still alive. So if you have like, 6 hours left, and if you wanted to change it for whatever reason, because it's active or something, you can change that time to live time as well. So it's all how you dictate it. You can also hop into the actual code base and change the core code base to how you actually want it to treat it. And also there are extra commands and options where you can make it a super fast time to live. So you can make it, milliseconds or things like that. So yeah, It's all up to you.
Well,
we are low opinion. Cool. That's a great question. So now let me actually show you a little bit about Redis modules. They're cool, and they're not that hard to implement and put on top of the normal Redis core. There are many different ways of actually running Redis and getting these modules running. I'm running it locally because I installed it. It's actually not that hard at all. It's easier and smaller than installing Node.js or something like that. You can run a Docker image, which is really great for when you want to try it but not buy it. When you want to try out a bunch of different modules and configurations, but you don't actually want to thrash your laptop with all this commitment, you can just run a Docker image, which is fantastic. And again, we do that. And we have a video on how to pick and choose and install and run different Docker images on our YouTube. Or you can use our cloud instance. Oh, I just saw a good question. What would I have been saying? What 2 milliseconds would be compared to do? I.e., how fast that compares? 2 milliseconds. That's human perception is like 10 milliseconds. I can't perceive anything faster than 10 milliseconds. So that's very, very fast. Below milliseconds, I'm sorry, I was looking at the chat and I just saw like what's the insignificance of 2 milliseconds. That's super, super, super fast. Anything below that's like nanoseconds, which is even more cuckoo bananas fast. There's a really great talk by Grace Hopper, who is the mother of all programming. She created COBOL, and I could actually give a talk about her. But she gives the amount of distance a light particle travels, which is the speed of light, in 10 nanoseconds. I think is 10 inches. And light speed is very fast. So in 10 nanoseconds, if it goes like 10 inches, that's very fast. But milliseconds are above nanoseconds, and it's just very fast, very, very quick. And you're accessing, again, this is very fast because you're accessing RAM, which is used for very, very short and quick retrieval. How does Redis speed compare to other similar technologies? That's also a great question. Because we actually connect with RAM and not a spinning disk or SSD, it's a lot faster. RAM is still multitudes faster than the sweetest SSD that you can come up with for now. I'm sure that's going to change within 10 years. It's faster. It's just way faster. SQL tends to work on hard drive architecture, and SQL has to usually group and amass SQL commands and relationships and build the actual output for you, whereas everything is just quick retrieval within Redis. That being said, if you want relationships, and often you really do, especially like many-to-many relationships that need to be updated often, SQL can't really be beat. You can fake SQL with Redis, but yeah, that's the trade-off. Redis is very fast if you know exactly what you want, and what you want is less complex on the back database end. So, right. So I'm gonna because these are all really good questions I want to answer, but I'm gonna hide them because I get like, ooh, shiny, distracted very easily. So I'm gonna talk about a quick little backend that I created. This is very, very quick and dirty and elementary, and it's creating a Discogs backend where it's just nothing but routes that you contact with different HTTP methods, and it basically does CRUD with Redis. So you will have probably seen this like in most Node Express, Mongoose, or PostgreSQL, things like that as an equivalent. If you actually want to follow along, the GitHub URL is kind of long. I'll share that in the chat. I believe I did all the way at the beginning of the chat, but it's bit.ly, and that that little slug right there. I made it softer for you. But let me actually switch over to let me open up, before I actually share with you, let me open up the IDE. And yeah, these are all good questions. I definitely want to answer more of them because I like talking. And I like answering questions because I don't want you to be left without questions here. But as soon as I'm done talking about our CRUD example, then we can sort of jump into that. All right, and let's just do desktop. All right, I'm gonna do the whole desktop. Why not? Let's do it live. All right, let me some more space. All right, so this is my application. And I'm basically CRUDing albums, just like discogs.com, where you can buy and sell and talk about albums. And these are all my different commands that I have for our routes. We can create, get all albums. We can search for albums by specific properties. We can get one album to look at the specific details. We can update the values of an album, or we can delete an album. And then I have this convenience route right here, reload, which is going to reload all of the hard-coded album data and make any necessary changes. So what I'm actually using now is, let me look at my package JSON just so you can check it out. Redis is the client library that is just been around forever. And we just recently, and by just recently, I mean like November, December, we started actually leaking this out. We started releasing Redis Ohm. Now, Redis Ohm is Redis object mapping. And that's, oh, I don't want to start Discord. I want to start, there we go. I'm going to put this up here. Redis object mapping allows us to actually store and index values, hashes, or JSON into Redis in a way that allows us to search very quickly. So this is us kind of like putting on our big boy SQL hat, and that we're actually giving them formal indexes and keys and things like that. We can actually do secondary indexes as well. This example is going to be very, very simple. I'm not going to show you all the capabilities of search because we actually have a whole class dedicated to search. And like I said, Redis Ohm is going to be updated in like by Friday. So there's going to be a lot of new changes that you'll want to actually check out. But there are more Node.js search examples out there that we have. So please check into our YouTube channel. Also, our developer page at developer.redis.com has a lot of code examples that we want you to try out. And you can try this one out and add whatever you want. So I'm using Express, Redis, the new Redis Ohm, which is publicly available, .env to hide just some environment variables, things like that. And then here are my routes. Not super, super cool. Here's what you want to see. This is my database config. Now, I'm not going to expect you to completely grok everything here. But basically, like I said previously, Redis accepts anything and everything, any way you want to throw into it. So you can throw HTML, base 64 encoding, binary, whatever you want into a string, and we'll accept it. That's great. That makes us, most of the way. But that's really crappy for search because search depends on some stability, some anchor, some things to do. So if you want to search by, in the case here, our albums contain artist. I want to search by artist, or I'm going to search by the title of the album, or I want to search for different formats. So if it's vinyl, I only want to see vinyl records. If it's CD, I only want to see compact discs. If it's cassette, I'm a hipster and I want to see cassettes, or, I'm a little bit older, which is true. So search requires indexed values. And here, text search true means basically, I want you to index these values and I want you to actually be able to search by them. So search by artist, search by owner, because Discogs has owners of records. So we're going to have owners as well. Search by title of the record, search by format, and then search by comments, because maybe you'll find something in comments like scratched. Well, I don't, I want to see, what's scratch, or I don't want to see scratch, or maybe I want to see first issue or reissue or special edition or something like that. So you can actually dig in there and see that. So just to formally go over these albums, we're going to CRUD artist, owner, title, condition, format, comments, price, and for sale. Now the type, we can put a couple different types in here: string, number, or Boolean. We can also store with, I'm using Redis JSON, which allows me to store and manipulate JSON within Redis. It's a module. We can actually add arrays as well, unlike hashes where we can't use arrays. We can have arrays of strings, of numbers, and of objects as well. So there we go. Now we can actually CRUD JSON. I'm not including objects because I couldn't really think of an array of objects that I could include for album, maybe song titles or something like that. But I might leave that as a task or a challenge to you later on. I'll talk about that later. But basically, I'm describing a schema very similar to MongoDB or Mongoose. I'm creating that schema. I'm saying I want this data structure to be JSON. Otherwise, by default, it's our in-house hash, which again is flat. There's no embedding of arrays or anything like that. And then I'm creating our actual client here by calling Redis Ohm URL. Now, this is actually my cloud. I'm connecting to the cloud. Why? No particular reason. I just wanted to show that I could use the cloud. And then I'm exporting all this. So now let's go into my controllers. And here I am actually writing out the code to CRUD my albums. I tried to keep this simple. There's no data validation for the most part. It's really kind of dangerous, and this will completely thrash and ruin everything, but whatever. All right, so I'm going to start off by switching databases. So instead of local, I'm going to connect to my cloud. And you can see I already have entries. These are what the entries look like: album, and then that is my actual index ID. I'm going to call here node mod. Oh, cannot find .env. Not a talk without actually having something break while you're presenting. Actually, I would consider that a failure if something didn't break. Okay, so we're looking good. My server is running. I'm going to bring in Postman. I talked to Danny a little bit, and she said that you have all kind of worked with something similar or this. So that's great. It just basically allows me to send HTTP requests. So I'm going to actually call my little convenience method of API reload. And that's going to go through my hard-coded album data and just throw it into my database. It's going to clear out everything, re-add it, and then re-index my database to make sure that everything is there. So gives me an OK. So now I have all these records here. Let's inspect a couple. Oh, I have to reset or reload. So here we go. Rosalie Cunningham, self-titled album, Rosalie Cunningham. Amazing artist. I have an extra copy of her self-titled album up for sale, still in the cellophane. Ooh, this is owner Suze, who is one of my coworkers, priced at $10. That's a really good deal. Let's look at another one. Tribes of Nurat. Ooh, adaptation and survival. Has a few dents on the gatefold, but otherwise in great condition. Comes with original stickers. Sweet, love stickers. Simon Prickett is the owner of that one. So we now know that we actually have data in our database, which is cool. These are all small little JSON objects of 64 bytes each. So that was me calling reload. You can actually go through that at your own convenience. That's actually not super exciting. Let's look at create. So similar to every other pattern of working with Express, we'll pull out a rec body the day that we send in with a post request. Since the condition and the price are both numbers, they're both integers, I'm going to ensure that I parse into those. That's one little bit of validation. Also, for sale is a Boolean. So I actually set it as, a quick little check to make sure that it coerces into a Boolean, not just a string Boolean. I haven't created a front end to this. I actually tried Vue for the first time. That's a very powerful framework and I liked it a lot, but I was like, I don't know if I want to make a Vue framework in front of a bunch of people that have spent the whole entire boot camp running that. So I'll let you do that. I'm more of a React person, for better or worse, So this album data right here is just an object that's been pulled from the user from any kind of HTTP request, prepped for delivery, and then here's the actual call to put it into Redis. Repository, which is what we call the search capable client, create and save, and then I passed in my album data. And there we go. That's it. I just created it. And then, the standard then and catch. So if it's good, I send it. If not, then I send back an error message. And that's pretty much it. It's not, it's not really too far fetched or out of the ordinary. Let me send a post and then see what happens. Let me put in the body. There we go. Let's see here, artists. Let's see, let me look at my band posters. The Smashing Pumpkins. Title, Siamese Dream, good album. Condition, let's give it a sad number. It's a very old album. Format, they don't have it in vinyl, so it's going to be a CD. Comments, it's kind of scratched. Has some teenage tear stains in the lyrics sheet. Because, I mean, we were all there at one point. But still plays. All right. And then, let's see here. For sale, I'll say true. And price, do I have price yet? No. Can I put a price on my childhood favorite album? Fire Sale, $8.99. Actually, let's set it to 8. So I parse into it. So it's a post to that for the create. Error cannot post. Oh, oops, my bad. Post to API/albums. And there we go. So now I just created a new album. Here's the entity ID, which is the specific indexing ID, so I can actually search for it later. And then here's all the data: artist, owner, title, condition, price. Notice that condition and price are actually numbers, and for sale is a Boolean, not an actual string. So cool, system works. And then I'll just refresh this, because sometimes I like to trust but verify. These are all the different albums. I'm trying to look for Smashing Pumpkins. Sorry for exposing you to my over dramatic music. Hopefully you'll take this and add. What? Okay.
No, just move on.
Let's move on. We didn't see that. Where is it? Ah, there we go. It was the first one. Smashing Pumpkins. So there we go. It was added there. So I now know that everything is in there. So the create works. That's great. So now we can speed up a little bit. Get all, where you just retrieve everything from your database. That's cool. But again, Redis prefers that you don't pull everything out of your database, because that's a lot to pull. And do you really want to, show somebody 30,000 records all in one view? That's going to melt their computer, and it's going to melt their little Chrome or their little Firefox. So I added an optional offset and count. And here I am actually using a little bit of the search capabilities. I'm calling repository search and then return. And that's basically saying, I'm going to search everything and then return page offset count. Offset count is like just a small chunk or a page from a large book of all of my values. So if nobody actually gives me a query parameter for offset or count, I'm just going to return the first 10, starting at 0. But if you actually give me optional query parameters, then I'll, give them to you, and you'll be able to get page 2 or page 3. Or some sites allow you to change the amount that you actually want to get back. So instead of 10, you want 50 or 250, things like that. So this is me actually contacting my database to receive exactly what I want. And then this is just the administrivia to actually send it back to the user. Get one actually uses that entity ID. So let's see here, this thing, this 01FWMT blah, 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 blah. That's the actual entity ID that you get back. And so you'll use that as your key, because I noticed that Vue, when you're listing objects, requires a key, just like React, a unique key. So that's your unique key. So if you were not using Redis Ohm or this search client, you would be generating that key dynamically based off of some unique value, which could be created at or last accessed or owner : title or owner or Justin Castilla : Smashing Pumpkins. That could be a key name if you wanted. But with Redis Ohm, the keys are dynamically generated on their own for you. So that makes it actually kind of easy. So this is get one. It looks for that one specific album by using the repository.fetch command. And there you go. It's even more similar than, easier than getting a get all. Search is you can get really far into search. It's kind of exciting. I wanted to keep it light and breezy because that's just me. So with search, it's a GET request, and it doesn't know specifically what you want. So you are going to send in search parameters. I'm calling it query with rec that query. So it's going to be query parameters, property and value. Here's me pulling out the property and value out of the query parameter object. And then this is me just searching for one thing. So repository.search is me saying, hey, I'm going to search for something. Give me everything where property matches value. So that could be anything from where artist matches Kailisa, or where title equals the Red Album, or where condition matches 7, or where comments matches first release. That's where it gets really magical. And this is just the absolute tip of the iceberg as far as search goes. I will include a link, and there is a link in the documentation in these repositories of how to access Redis Ohm. It's just that, it's available on NPM, but it's also in our GitHub. But there is, where numbers are greater than this, but less than this, or where the words contain this, or words do not contain this. Search is pretty huge because it has to be. We have to have a lot of different filters to find the actual data that we want and not all the crap that we don't want. So it's definitely worth, a little bit of a lunch break or after work or something, just to look to our Redis Ohm and our Redis search, because it's really cool. The person that's writing it, Guy, he has a bigger beard and he's louder and he has a more weird background than I do. I love him. He's writing this and he's trying desperately to make it as close to normal human speech as possible. So I give him feedback when he's making all these new revisions, and I ask people for feedback. So if you ever end up using this, please let us know what you want, because literally we are the people that create this. Developer advocates make sure that it's good for developers. We're advocating for you, because our normal developers, they don't really think about other developers. They're thinking what they want to do very quickly. So it's up to us to actually make sure everybody's happy. So that's my speech. And this is searching. So this is just, we're getting all that match this property and that value. So if I had multiple, say, property is artist matches Smashing Pumpkins, this would return all artist values of Smashing Pumpkins. So that's that. That's search. And then update, it's kind of fun. Update with Redis. We don't really have an update. You just write it over. We don't care exactly. Because with the strings, if you remember me saying like set foo bar, like just declaring it, you don't have to declare a value beforehand. So you just bam, overwrite the data. So updates require the specific entity ID. because we want to know what we want to update. And it also requires data to update within that value. So here I am getting the entity ID and the updated data from the rec body and the rec params. This is also me making sure that price and condition are parse-inted. So we're converting them to numbers, not strings, just make sure my data is tidy. So here I am actually finding that one album, repository.fetch entity ID, and then album entity.data equals object.assign album entity data update data. This is kind of an interesting one, and I'm calling the object prototype, which is always a little like, what are you doing? This is me just taking update data, the stuff that I got from the user, mapping it, but not overwriting completely what I have in my database. So that allows me to take one or more or none changes, map it over my existing object without deleting anything accidentally that I don't want to delete. So if I misspelled dream in Siamese dream, I will update Siamese dream, but I won't change format or comments or artist accidentally. So that's just my little thing. And then after I changed it, I save it. So repository.save, and I pass in that newly updated album. And then that's it. And that's, basically CRUD. We have delete. Never forget delete, because people love deleting. And delete needs an entity ID, so we get that passed in via our rec params. And we simply call it repository.remove and pass in the associated ID. And that's it. So it will delete that as well. Now, if we're not using Redis OHM, this Redis search specific library, we will have to just create our own keys, which again, isn't that hard, isn't that bad. You just have to be kind of mindful and thoughtful of how you do it. Honestly, just create a function that does it automatically and you're good. And again, just a little aside, the way that we generate our keys in like our tutorials and all of our code bases and in Office is we have everything, separated words, colon, other words, colon, maybe like some internal ID that is helpful, and then some other word. So maybe user colon Justin Castilla colon followers. Just by reading that key, you kind of understand what I'm talking about. Or it could be user colon Justin Castilla colon friend colon Simon Prickett colon chat log. And so that might actually contain, this is a whole key. It's big, but nobody cares. Most of the time, we're not even looking at the key. This is all read by computer. This might contain the entire chat log between me and my friend Simon within our service. And so we can actually programmatically design that key on the fly. It's super fast. So it's never too much of an issue. And let me go back here and there's actually nothing to show here. We actually saw everything. I invite you to actually play with this. I actually talk more in depth, very much in depth, how to actually get this up and running, how to play with it. I talk a little bit about each specific command. I have a routing table, some example routes that you might do, things like that. Because I want you to actually play with this and see if you like it. So yeah, that is our newest thing. I mean, this is like kind of steaming at this point. We haven't, this is all released. This is all fresh and new. But I've actually been changing what I want to talk about for this for quite some time because our technologies have been changing so much. One last treat before I actually let you go, or we actually open up for more questions. So Redis works on OS X. Redis works on Linux. To run Redis on Windows, you do need to actually install the Windows Linux subsystem with Windows 10 and Windows 11, which isn't too hard. It does take some steps, but basically what you end up doing is running Windows WLS and then running Docker on Windows. And we have videos on our YouTube on actually how to do that. But the coolest thing, personally, I feel, this is a little 3D printed Redis logo. Ooh, it's very pretty. It won't focus, but it is very pretty. But the cool thing is Redis will run on a Raspberry Pi. This is a really big Raspberry Pi. This is 8 gigs. So that's more than I would ever need for my own work. But we could actually run it on a very small Raspberry Pi, a $20 computer Raspberry Pi unit that has maybe 512 megs, something like that. So it's kind of fun. Redis is really fun for actually thrashing against the database if you want to do a production where you don't want to constantly have to up and down and roll back and re-roll your database. That's fantastic. But if you if you want to do some really fast prototyping, you don't want to worry about your database, consider using Redis. I mean, you could use, a Raspberry Pi connected to your network, and you can just have everybody thrash against that. That's kind of fun. So I'm going to go back to the slides just for some housekeeping and some farewells. I would love it if you wanted to know more. There's a lot of cool stuff. And our courses are really interesting in that we want to show you how to integrate Redis into actual production environments, how to actually run it in a mature way, not just like, hey, look at me, I made Smashing Pumpkins albums. That's good for talks. So we actually have an entire university. So if you know Java, you can take our Redis for Java developers. I recommend you take our JavaScript developer course. That's a really good one. Python is relatively new too, so that's a great course. And you can learn about streams, which is on its own a very interesting thing to do. I actually helped out with querying, indexing, and full text search and Redis security and running Redis at scale. So if you can handle me for long periods of time, go ahead and check out those videos. Running Redis at scale shows you how to explode the amount of Redis that you have across the globe, so your reach crawls all over the place. And it basically says, hey, if one of your data centers should die or fall or fail, it's not the end of your data. And honestly, we store in RAM our data, but that's not dangerous because we actually append every single key to a file that we write out to a hard drive. So I didn't want to talk about that a whole lot because I don't have a lot of time, but basically for everything that we're creating in our RAM, we're also creating a shadow copy, a backup on a hard drive. It's optional and you can configure it, but that's what we do. So yeah, if you wanted to actually go forward with Redis University, I recommend Introduction to Redis Data Structures. It goes over all the data structures that I've covered and then some. And yeah, it's pretty cool. If you don't want to take a university course, I don't blame you. You were just in boot camp or you're going to be in boot camp, so you're going to be really busy. We have a lot of YouTube videos and you can see me in there. I dress up in weird things and I'm kind of kooky because I think that it's important to learn and enjoy yourself, because if you're bored and you're learning, that you're not going to retain it at all. So we keep it relatively light and fast. 10-minute max, gives you code examples with the command line interface. It's not just me, other people, my manager, Simon, my buddy, Simon, Guy in the bottom right there, you can see his beard. It's ridiculous. Ghost hunting with Redis. That's pretty neat. And yeah, it just we show you how to do all sorts of daily things, little trivial things with Redis, and also big things with Redis. So sometimes we have talks that are an hour and a half, and that's if you really want to get into machine learning or setting up kind of mature level, code ready, production level instances of Redis with some sort of feature, mainly search or machine learning, AI, things like that. Is it a hot dog? Is it an iris? You'll be able to find out with Redis. Also, if you just want to ask questions and things like that, you can join our Discord channel. I'm active on it. All of us are active on it. All of the dev advocates. Even just being a fly on the wall is really cool in this channel, because people are asking. You can see in this slide, somebody's asking a very detailed question, and there are two two different developer advocates that have answered. So this Discord is a working Discord in that we actually answer and advocate for Redis and answer questions that people might have. Also, there's tons of different rooms. So if you're asking a question that you're a little shy about and you want to ask like a one-on-one or an actual help-only question room, that's totally fine. There's no question too great or too small. So thank you for listening to me talk a lot. I know that it's dinner time, and I know that you're going to be learning a lot, have learned a lot, or just got back from work or something like that. So I appreciate it. I truly do. Follow me on Twitter, email me, tell me you were loud and obnoxious, whatever you want to do. Join one of our things and keep in touch. I love talking. If you have specific questions or if you want to talk about something a little bit longer or anything about I'm an advocate for developers. So it's not just about one technology. I want to make other developers more empowered to do whatever they want. So if you have any questions like that, I'm more than happy to talk one-on-one. But other than that, I would like to stop sharing. Also, that's Grace Hopper. Please do your research on Grace Hopper and send your love of Grace Hopper. I want to hear some questions if anybody has any. Otherwise, I could go through the chat window or something like that. I know there was a lot going over. So if you have any things that have been around, let me know.
Stacy has a question.
Nice.
I do have a question. Yeah, I have a question about caching. So in the example that you had earlier, you had some items with an expiration time and some items that didn't. If you were to quote unquote clear the cache, how does that work in Redis? Does it get rid of everything with an expiration date? Does it get rid of specific things? How does that work?
Yeah, good question. Well, yeah, there's like a lot of different layers of caching between the web application and you. So clearing your cache, like on your browser, would clear your specific browser's caching of our data. And that actually won't affect us because that doesn't send us any information. So when I'm talking about like Redis as a cache, it's kind of like my own cache before I give you that information that I have. I look in my cache. So I'll use.
Yeah, that actually is what I mean. Like as a developer clearing the cache. Like,
okay. Yeah.
How does that work?
So clearing the cache, you generally don't want to completely get rid of your cache. Otherwise, the experience of the user is going to be pretty slow. When you saw like some that didn't have TTL, those are actually remnants of previous keys that I was playing with. When I am creating a cache and implementing a cache, everything has a TTL. Unless there's like some very significant thing, like a news item that is just like breaking our servers, or some piece of data that is just constantly being consumed, like a #1 hit song or #1 piece of media, I would probably loosen the TTL on that to like indefinite or 12 hours as opposed to like 1 hour. But for the most part, I would never have an item in my cache that did not have a TTL because Redis, again, is super, super fast, but it's also more expensive. RAM-wise, RAM is much more expensive right now than hard drive. So space is a bit of a premium. So when you actually get full, Redis will logically remove items based off of how you do it, an eviction policy. Some people might have heard LRU, least recently used. Redis will go in and say, well, there's 20 minutes left on this key, but it hasn't been used in a very long time. So I'm just going to kick it out so I don't have a hang up situation. But yeah, what you're seeing with me and my Redis Insight, that's basically just like me sandboxing. So
Makes sense. Thank you.
yeah, cool. Good question. Any other questions?
I have a question from James in the chat.
You guys at redis.com behind the official Redis container image, or do you make your own? What about Redis to go on Heroku? Good questions. So yes, we are behind the Redis container. It's pretty cool because you can look at those images. You can actually see the bleeding edge. So 7.x different versions. So we are creating those. I actually recommend if you're into the Docker image route to look up Redis Mod, which has all of the Docker modules just wrapped inside. So if you want to take it out for a test bin, go for it. Redis to go on Heroku. I don't know. I don't see Heroku talked about a lot in our hallways on Slack. So I don't think that we have such an official capacity of relationship with them. But that being said, it's kind of weird because I'm Redis Inc., but Redis Inc. is partially Redis. So they're using probably the same version as we are. It's not going to be a huge difference at all. But that is actually important to check because sometimes some commands have changed among versions. We don't make breaking changes to the core Redis, but all the newer, cooler features you'll want to look at for the newest versions. I'm not quite sure what Heroku actually has for a version, but that's a good question. And I'll actually find that out because that's good. It's good to know. Yeah, let me see here. Ooh, look at you all talking about code. I love that. Oh, Madame Zuzu's tea shop. That's great. I haven't been there either. I really want to go to.
Yeah, we kind of quipped a lot in there.
Weather is a hoax. I actually believe that. I never looked at. I'm originally from Seattle, Washington, so it's just shitty outside. But what's the weather? Shitty. I don't have to look
It's
outside.
just crap.
Yeah.
Do you guys have other questions for Justin while you have him here?
Yeah, and it doesn't even have to be a Redis. Like, how on earth did I get to be a developer advocate?
Vinny's got a question. What's up, Vinny?
Oh,
Yeah, I actually, we use Redis where I work, and I haven't touched it or looked at it yet. But they have me like moving through everything. So Angular, RxJS, PHP, and I move around a lot. So I can't really schedule learning at work. And I noticed a lot of the Redis University courses like have start and stop times. Is Redis Cloud essentially like a Udemy style buffet of those course videos, or?
yeah. So we have start and stop simply so we can actually do some basic statistics and tracking of like how many people actually take our course. It's buffet style, so it's self-paced. We just close it down whenever we make any changes, slight, small wording changes. So you don't actually have to worry about it. Like, you need to be on schedule to see me talk live. We used to do that, and then I was like, this is not fun for anybody because people are living lives. So yeah, it's completely open to you. We say it's a 5-week long course, but normally people finish it within like 1 or 2 weeks, depending on how much you're actually enjoying it. A lot less videos and more of just like you reading and trying it out in the end. So yeah, the newer classes that we're making are actually shorter too. So
Pandering to the millennial lifestyle. Are you, Justin?
I just don't want to. Reading off a script for like 8 hours is just like. But yeah, we offer shorter classes because our technology is getting faster and faster as far as what we're releasing. So I'm going to be talking about the newer version of Redis Search with JSON. That's the next course that I'm going to be shooting. We also have a developer certification course. So if you take 3 different prerequisites, you can take a bigger exam. And if you pass, you get to have a developer certification badge on your LinkedIn. And we vouch for you, which is pretty cool. I actually run that. So if you ever have any questions, ask me on that.
I have a question, Justin. Can I not do the courses and get the badge from you since we're friends?
Yes. I think I can do that. I can pull some strings. If you can answer 80 questions within an hour and a half on deep Redis, I will give you that opportunity.
Okay. All right. That sounds like a shortcut and I'm going to take it. Thank you.
Cool.
Other questions from you guys?
Cool.
This was very informative, by the way, even for me, who knows very little about Redis. This was great. And I was able to, and hopefully the rest of you were able to do the same thing, relate what Justin was talking about with services and technologies that I already know and kind of compare them and be able to understand, oh, okay, this is the way that this does it. This is something that I already know. And that's really what developers do overall is we make relations in our minds to things we know and a new thing that we're learning.
Yeah, absolutely. When I first started at Redis, I didn't really actually know a whole lot about Redis. Just faked it. But I did know quite a bit about Mongoose and MongoDB. So I did a lot of comparisons and contrasts with that. And I was like, oh, this is easy. It's just Mongoose and RAM with like data structures, no schemas. Oh, now we're doing schemas. Okay. So yeah, it's totally fine. Once you know one thing and you get pretty comfortable with something else, it's all just like, C is an angry Python. What's Python? Python's a very astute Ruby. What's
Yeah.
Ruby? We love Ruby.
We love Ruby and Ruby loves you.
Yeah. And that's what you do in the end. So.
Other questions before we wrap up here?
Well, I want all of you. Oh, yeah, Michael.
Yeah, I think I know the answer to this, but maybe I missed something in the code, but it looked like in your search example, it looked like when you actually pinged the Redis database, you were only looking for the one key value pairing, but I assume you could chain those together. So if I wanted all the hard rock albums from 2005, it would then do that.
That's actually the breaking change that's coming out on Friday. We're going to be chaining different search values. So yeah, multiple. I want bands from the Midwest, from Saddle Creek Records, things like that. We can actually chain those, and you can build those dynamically, and that's going to be coming along really soon. Yeah, you know it. You're not a plant. I did not pay Michael before this to ask me such a beneficial question.
I might have.
There you go.
No, actually, it's interesting. Like Vinny, we actually do use Redis at my company. I have no idea what we actually use it for.
Yeah.
Haven't gotten it because it's a huge, complicated app, but I know some of it is just to avoid our database getting just hammered.
Yeah.
When you scale, it ties into the speed question, but some of that, getting back to some of the questions people had in the chat, is I assume it's just your database can just get clobbered when you've got tens of thousands of users going at it simultaneously.
Yeah. Yeah. And it sounds like it would be used as a message queue or a quest queue or like a cache where it's just, yeah, it just takes away some of the back pressure on databases, which I'm more than happy when that happens. When I worked at Sauce Labs, we used Redis. I was like, oh, what do we use Redis for? And they're like, I don't know. Let me ask one of our coworkers in Poland. And I was like, hey, Poland coworker, what do you use Redis for? He's like, oh, message queue for some uninteresting message ID that we do for some uninteresting feature. I'm like, okay, cool. So yeah, we're kind of everywhere for better or worse. It's not romantic or sexy at all, but that's cool. A lot of people don't know that we can actually do some cool stuff. So that's why I'm here.
Awesome. Any last questions to throw out before I end our session today?
James, can Justin hang on after the recording? Quick?
That's the separate. I have an additional question I just wanted to ask you about real quick.
Oh yeah, what's up?
Is fake Redis still the go-to for testing Redis interaction in Ruby apps that you know of, or is there some sort of new fancy toy that is better that you're seeing out there?
I haven't heard of any other new alternative.
Okay.
Yeah, other than just writing your own testing suite, your own testing scripts. So I think you're on a good path there.
All right.
Cool.
I want to thank Justin so much for doing this lesson and helping me organize this and put this together. We appreciate it so much. This has been very informative and super helpful. And to anyone who's going to be watching this in the future, hello from the past, but also this will be very useful to you as well, I hope. Super informative. So again, thank you so much, Justin. I put a bunch of links in the Zoom chat for you guys. If you want to follow up with any of that, that's all there. If you guys want to connect with Justin, send Justin an email, justin@redis.com. If you want to relay anything through me that I can send to Justin, if you forget all this information, feel free to do that too, and I can always pass things along. So yeah, with that, I think we're going to stop our recording for the evening, and that's going to do it.
Happy Wednesday, everybody, and keep in touch. I hope to hear from you soon. And